Hey there, deep diver. Ready for another deep dive? We're really going deep this time into Stephen Wolfram's A New Kind of Science.
Oh, yeah, this one is dense.
It's really something. I mean, this book is packed with enough mind-bending ideas to make your head spin. But don't worry,
We'll try to make sense of it.
we've got you. We're here to guide you through the most fascinating parts, those aha moments that can change how you see the world. Wouldn't you say so?
Definitely. And Wolfram doesn't make it easy, does he? The guy spent years on this, even built his own software company.
Mathematica, right.
Yeah, Mathematica, just to support his research. Talk about dedication.
Talk about commitment. Okay, so right out of the gate, Wolfram really throws a curveball.
Hmm.
He challenges this fundamental idea about complexity.
You know, the idea that complex things have to come from complex causes.
Exactly. We usually think intricate things need intricate explanations. But Wolfram says, nope, he basically throws that idea out the window.
It's remarkable, really. He shows how even incredibly simple rules, like the kind you'd find in a basic computer program, can create these crazy complex patterns. Imagine your favorite symphony,
Okay, I'm listening.
composed by a calculator.
Now that's an image. But how does he actually show that in the book? What's his method?
So he uses these things called cellular automata. Now, before you tune out thinking it's some crazy technical jargon,
I'll admit it sounds a little intimidating.
it's actually pretty simple. Picture a grid, right? Where each square can be either black or white. Then you set a simple rule. For example, if a white cell is surrounded by one black cell, it turns black in the next step. Simple. Okay.
I think I can visualize that.
Yeah.
What happens next?
You let that simple rule play out across the entire grid. What Wolfram discovered, and it's really quite revolutionary, is that even with rules you could scribble on a napkin, the patterns that emerge become mind-blowingly intricate. He even has a whole section on Rule 30.
Rule 30.
Yeah, it creates this wild, almost chaotic-looking pattern from this dead simple rule.
That's amazing. And this is where those seashells come in, right? The ones with those intricate patterns. It's incredible how something so naturally complex could come from simple rules repeating over and over.
It really makes you rethink everything we thought we knew. And Wolfram doesn't stop at seashells. He suggests that this principle of simple rules behind complexity might be fundamental to everything: physics, biology, even intelligence itself. It's a lot to take in.
So we're really talking about simple rules, creating incredible complexity. That's a pretty big leap, isn't it? But how does this actually work in real life? I mean, does Wolfram give us any real-world examples?
He does. He points to those seashell patterns we were just talking about. You know, the unique markings on a giraffe.
Yeah.
Even something as basic as the way water flows, all turbulent and chaotic.
You mean those could all come from simple stuff happening over and over again?
Exactly. It's like mind-blowing when you really think about it.
It is. But there's got to be a catch, right? It can't be that simple, can it?
Well, you're right to be skeptical. Wolfram argues that even though the rules might be simple, the complexity they make creates a kind of barrier. It's like trying to predict, let's say, the exact order of cards in a shuffled deck.
Okay, I see where you're going with this.
You get the idea, right? It's possible, but there's just so many possibilities that it gets really hard really fast.
So you're saying even if we know the rules, it's still almost impossible to predict the outcome.
Exactly. And he brings back that Rule 30, that cellular automata thing we were talking about. You remember how the rule works, right? But could you really tell me what pattern it'll make after, like, 1,000 steps, just by looking at the rule?
I don't think so. You'd have to actually run it, right?
Exactly. Wolfram has a name for this: computational irreducibility. Basically, it means that for certain things, there's no shortcut. You can't just whip out some fancy formula. You have to let the system play out step by step.
So even with these simple rules, some things are still unpredictable. That's kind of unsettling, but also really exciting. So does that mean that even if we find those basic rules, there are still mysteries we might never solve?
Absolutely. And this unpredictability is what leads Wolfram to question if our usual tools are even enough to handle this kind of complexity. He says that traditional mathematics, while powerful and elegant, might be too limited for this.
He's not saying we should just toss out math altogether, is he?
Not exactly. But what he's saying is that we might need entirely new ways of thinking, new tools that go beyond traditional math to really understand this universe that a new kind of science is showing us. It's like a call to rethink the very limits of what we can know. Imagine whole new types of math just to make sense of this complexity.
It makes you wonder what we might be missing by approaching these complex things with our current way of thinking. What else does Wolfram say?
Well, he talks about this idea of picking the right model for what you're studying. He says a lot of the models we use, even if they look good on paper, they don't really capture the real complexity of the thing they're trying to represent.
So it's not just about finding the right rules, but finding the right way to even think about those rules.
You got it. He even questions how we as humans perceive and analyze data. Wolfram suggests that our usual ways are too focused on simple, repeating patterns. And that, he argues, could be blinding us to more subtle kinds of order that might exist in these complex systems.
It's like trying to understand a symphony by only listening to one instrument.
That's a perfect analogy.
Mhm.
And Wolfram takes it even further. He suggests that this limitation in how we see things might be a big reason why we haven't found any hard proof of aliens yet.
Wait, aliens? How did we go from talking about seashells and stuff to aliens?
It's actually a pretty interesting thought. He says that if alien civilizations exist, they might be using way more complex ways of thinking and analyzing than we are. They could be communicating or sending signals in ways we can't even recognize because we're stuck looking for simpler patterns.
So we're not just limited by the universe being complex, but by our own limited ways of understanding it.
Exactly. And this brings us to another important point Wolfram makes. This computational irreducibility, this limit on what we can know. It's not just for big, complex systems. It pops up everywhere, even in simple computer programs.
So you're saying even a simple computer program can do things that are impossible to predict without actually running the program?
Precisely. He talks about something called a Turing machine. It's a theoretical model of how computers work. And even with really simple rules, a Turing machine can do things you just can't predict without going through each step.
So this computational irreducibility isn't just a scientific idea, it's like a fundamental limit on what we can ever know, even with computers.
Exactly. It's a powerful idea that goes beyond science into the world of computers, showing us that there are limits to what we can predict and know.
Okay, I'm starting to see how big Wolfram's thinking really is. He's connecting physics, biology, math, computer science, even the search for aliens. It's all connected.
You're getting it. And goes even deeper than that. Wolfram even talks about the very nature of space and time. He says that at their most basic level, they might not be this smooth, continuous thing like we usually imagine. Instead, they might be more like a network of connected points.
So instead of a smooth sheet of space-time, it's more like a complex web.
Exactly. And this web idea connects directly back to his work with cellular automata. He shows how networks themselves can grow and change according to simple rules, just like those cellular automata. And that could be how these complex structures we see in the universe came to be.
It's amazing how Wolfram ties all these ideas together. Simple rules, unimaginable complexity, unpredictability, and the limits of what we can know. It's like he's building a whole new way of looking at the universe.
He is. And through it all, he actually has a really optimistic view. He says that even though the universe seems crazy complex, it might actually be governed by one surprisingly simple rule, a rule that we might even be able to figure out someday.
So even with all this talk of unpredictability and limits, he still thinks we can find a theory of everything. That's a bold statement, to say the least. And A New Kind of Science is a pretty bold book, wouldn't you say? It feels like Wolfram really wants us to rethink everything we thought we knew about how the universe works.
Absolutely. And he doesn't shy away from the big questions either. He even gets into the nature of intelligence itself. Like, what does it even mean to be intelligent? And how does that work for humans versus, say, artificial intelligence?
That's right. He does connect it all back to intelligence. What's his take on that?
So Wolfram thinks that computation might be the key to understanding intelligence. He suggests that even thinking itself could be a form of computation, built on, you guessed it, simple rules.
So our brains are basically just incredibly complex computers. I don't know about that one.
It's definitely a big idea, with a lot of implications. Wolfram knows we still don't fully understand the human brain, of course. But his point is that these same principles, simple rules leading to complex behavior, could apply to intelligence, too. He even suggests that consciousness itself might come from these computational processes.
Wow, that opens up a whole other can of worms about what consciousness even is. But it's definitely an interesting thought experiment. It seems like Wolfram's work goes way beyond just science into like what it means to be human.
It really does, and highlights his point that a new kind of science isn't just about science, but about knowledge itself. How we get it, what we can know, what we might never know. He even questions if our traditional ways of doing science are enough to understand all this.
And that's where undecidability comes in, right? The idea that some things might just be impossible to know for sure, no matter how hard we try.
Exactly. He says it's not just some abstract idea, but a real thing. He gives examples of how undecidability pops up even in simple systems, like those cellular automata. He shows that even if we know the rules perfectly, there are still questions about what the system will do in the long run that we'll never be able to answer with certainty.
So even with all the knowledge in the world, there are still limits to what we can know. It's kind of a humbling thought.
It is, but it's also exciting, in a way. It means there's always more to discover. Wolfram's work is like opening a door to a whole new kind of science, where simple rules can lead to mind-blowing complexity, and where the search for knowledge is an adventure in itself.
So, deep divers, what have we learned today? We took a deep dive into Stephen Wolfram's A New Kind of Science. And let me tell you, it was a wild ride. We saw how simple rules can create mind-boggling complexity. We questioned everything we thought we knew about the universe. And we even explored the limits of knowledge itself.
We bumped into this idea of computational irreducibility, where sometimes you just have to let things play out to see what happens. And we wrestled with the fact that unpredictability is kind of baked into the fabric of reality.
We saw how these ideas could change everything, from how we understand patterns in nature to how we search for life beyond Earth.
And we're left with this big question. If Wolfram's right, and the universe really does run on one simple fundamental rule, what other incredible secrets are hiding in plain sight, just waiting for us to uncover them?
That's something to think about, deep divers. Until next time, keep exploring those strange and wonderful corners of the universe.